Hello there. In this video, I'm going to be showing you how to prove that velocity is the rate of change of displacement with time. I'm also going to show how acceleration is the rate of change of velocity with time, or the second order derivative of displacement. I'm also going to show you how to obtain the velocity from the acceleration where you integrate with respect to time, and I'm going to show you how to obtain the displacement from the velocity. So here you integrate with respect to time. So in my previous video, you can find the link to it below this video. I show you how to get these equations over here. And with those equations, we are going to be getting these formulas over here. Sorry, my voice is a bit rough because I just woke up. But anyway, let's continue. So let's start off by showing that acceleration is the rate of change of velocity with time. As you can recall from my previous video, v, which is final velocity, is equal to u, which is initial velocity, plus acceleration times time. With this, we can show that acceleration is equal to dv over dt. Now, we are going to show this using basic differentiation rules that can be found in A-level mathematics. Now, when you're differentiating, when you have a constant, that constant becomes zero. So when we differentiate this, when we are looking for dv over dt, this u over here is just going to disappear. Now, recall from A-level mathematics that if y is a times x to the power of n, then dy over dx is equal to a times n times x to the power of n minus 1. Using these rules, we can show that acceleration is dv over dt. So for dv over dt, we know that we cancel the u out, and we get a times 1 times t to the power of 1 minus 1. And that is a times t to the power of 0. And t to the power of 0 is actually 1. So what we have here is just a. So we've shown that a is dv over dt. In other words, acceleration is the rate of change of velocity with time. Using similar rules, we can get the second order derivative of displacement with respect to time. Using these rules over here, what we get is dx over dt is equal to u times 1 times t to the power of 1 minus 1 plus a half times a times 2 times t to the power of 2 minus 1. This gives us u times t to the power of 0 plus at. T to the power of 0 is 1. So what we have is u plus at. And this is in fact v, as we can see up here. So with this first step of finding the rate of change of displacement with time, that is dx over dt, we've shown that velocity is the rate of change of displacement with time. Okay, so that's the first formula up here. We already showed this, but we're showing this. Now what we have to do is get the second order derivative, okay, of displacement with respect to time. Okay, so we're going to have to differentiate this over here once more to show that it is equal to acceleration. From our previous work, we showed that v is dx over dt. We also showed that a is dv over dt. Now dx over dt is u plus at, which is v. And we know what we get if we get dv over dt. We get a. So if we differentiate this again, which gives us this second order derivative, we are going to get dv over dt. Okay? And that is a. So we've shown that a is the second order derivative of displacement with respect to time. This over here is fairly straightforward, and if you want to, you can use these differentiation rules over here to prove it yourself. Now let's show that to obtain the velocity from the acceleration, you integrate with respect to time. Over here we have a is dv over dt. If we integrate both sides of this equation with respect to time, we get this over here. And this up here gives us this, okay, because we have dv over dt and dt over here. And from here, we simply get v is this over here. So we've shown that to obtain the velocity from the acceleration, you simply integrate with respect to time when you have this equation over here. Now finally, let's show that to obtain the displacement from the velocity, you integrate with respect to time. Over here we have v is dx over dt. If we integrate both sides of this equation with respect to time, we get this over here. And because we have dx over dt and dt over here, what this leaves us with is this. So simply, we have displacement. Okay, to obtain the displacement from the velocity, you integrate with respect to time. And that's all. If you require basic integration help, then I would recommend reading C1 Mathematics, this book right here. It's been great for me. You can find these books in my Amazon store. I've left a link to my store below this video, so go and check it out. If this video has been helpful to you and you want more mathematics proofs, make sure you are subscribed to my channel. Alternatively, for algebra help and other mathematics proofs, visit mathematics.proofs on Instagram. Thanks for watching, and I'll see you in my next video.